Many people hold the misconception that stealth technologies only exist in video games such as Modern Warfare and Halo, as well as science fiction movies such as Harry Potter. This is false. Many militaries around the world are embracing stealth technology and using it in daily operations, which also debunks the myth that stealth technology is only used in special operations such as when SEAL Team 6 took down bin Laden. Stealth technology works in one of two main ways. The first being the aircraft having a shape that reflects the radar signals away from the receiver, and the second being absorbing those signals entirely, meaning that in both ways the receiver doesn't get the signal back, signaling that the aircraft is approaching. The first people to start trying to use stealth technology were the Germans in World War I. And what they did was they started with transparent polymers, namely cellulose acetate, in attempts to hide the aircraft only visually. They ran into two problems. The first being the fact that the polymer used actually reflected the sun more than it did hide the aircraft visually. And the second was the fact that the polymer degraded fast up at high altitudes and high speeds due to these high altitudes and high speeds, as well as the fact that the sun was beaming down on it day in and day out. After this, they went on to develop a silent engine for a blimp. It was a black blimp-like aircraft used to surveillance during the night, but provided little useful intelligence despite the fact that it did work to what they wanted it to do. After this, the Germans entered World War II and began to actually develop the stealth technology in the Horton Ho 229. The Horton Ho 229 had plywood wings that were reinforced with a charcoal/sawdust plywood resin which absorbed these electromagnetic waves from the radar. The bomber was almost totally invisible to Britain's early detection radar when it flew between 50 and 100 feet and at around 550 miles per hour. U.S. Operation Paperclip seized these German Wunderwaffe weapons, including the Vamp Vision, mine-clearing heavy tanks, long-range ballistic missiles, and the Horton Ho 229. These blueprints were believed to be given to the Northrop Corporation, and they are also thought to have inspired some of the modern-day U.S. designs, such as the B-2 Spirit stealth bomber. Modern design objectives differ slightly from those that were seen in World War II and World War I, in the fact that the main focus is on reducing radar cross-sections to disperse the waves from the receiver, as well as putting a little bit of emphasis on reducing infrared detectability due to thruster thermal emission, afterburner thermal emission, as well as IR detectability in harsh weather conditions. The last two design objectives are reducing radar detection by optimizing the aircraft's configuration, which came with the introduction of the split rudder, as well as reducing radar detection when it opens its weapons bay, which can possibly multiply the radar cross-section of a given aircraft by up to 10 times. Now, with these design goals comes design limitations. The first being that stealth aircraft, especially early iterations of stealth aircraft, were so optimized performance-wise, minimizing the radar cross-section, as well as being optimized in the fact that they are made of these materials that can absorb radar signals. They weren't optimized how a normal aircraft should be. They were poor aerodynamically and were unstable on all three axes, which required a flight correction by a fly-by-wire system. Another limitation is the fact that stealth aircraft lack afterburners for obvious reasons, and thus perform poorly in dogfights. This isn't a huge problem because these aircraft are commonly used as bombers, and recent improvements have made stealth aircraft much more aerodynamic, as well as improving their flight control systems, engines, airframe construction, and materials, although it still poses as a problem. Some stealth aircraft rely on an optimized radar cross-section in order to remain unseen by deflecting the waves away from the receiver. Opening weapons bay doors multiplies these radar signatures and makes them vulnerable to attack directly before and directly after they drop their load. Some modern-day stealth aircraft can open weapons bay, release ammunition, and return to stealthy flight in less than a second, although it still does pose a slight problem because they will see the blip on the radar. And although stealth aircraft require much less cover fire from supporting aircraft because of the fact that they are relatively unseen, they have heavily reduced payloads due to design constraints, which means more aircraft have to be deployed in order to do the job that a non-stealth aircraft could do in possibly one or two aircraft. Since stealth aircraft are constructed with radar-absorbent materials, namely carbon-enriched materials and tiny iron spheres, among other classified materials, they cannot take too much damage due to sensitivity, being that the materials are primarily focused on being stealthy and not sturdy. The last big limitation is the fact that stealth aircraft can generally accumulate costs much more than non-stealth aircraft do after you calculate the